Welcome back to part 2 of surds and rationalizing the denominator, exercise 12.5. Now, hopefully you've done questions 1 to 3, or if you've decided to keep watching, that's fine. I'm going to look at this one here, 2 on divided by the all of root 3 plus 2. There's a kind of a secret bracket around that bit there. This one's a little bit more complicated because I can't just simply multiply the bottom, or to get rid of the surd on the bottom, the root 3. I can't just multiply by root 3. If I multiply by root 3, I'll show you what I get. Becomes root 3 on root 3 becomes 2 root 3 on root 3 times root 3 will be 3, but then I'll also get root 3 times 2, which is 2 root 3. Well, I guess what I did then was, I probably should have shown you this, but I did root 3 plus 2 multiplied by root 3, and I sort of expanded that out like there. Again, I've still got this square root on the bottom, which is not what I want. So that was utterly useless, really. I'm going to rub all that out because it wasn't helpful at all. In order to get rid of the square root on the bottom, I actually need to multiply it by something called the conjugate. Now, the conjugate is an interesting word, I guess. The conjugate, I've got this written down here, it's always the same numbers, but the inverse sign. So if it was a plus, the inverse sign will be a minus. If it was a minus, the inverse sign would be a plus. By multiplying by the conjugate, you'll always eliminate the surd terms, and it will be made rational. So, let me show you a couple of examples of conjugates first before we apply it. So, if I've got root 3 plus 2 in this case, the conjugate to that will be root 3 minus 2. Same numbers, just change the sign. Negative to positive, positive to negative. If I have a look at the next one, root 7 plus 5, then the conjugate will be root 7 minus 5. The next one, 3 root 2 minus 5 root 3, then the conjugate will be 3 root 2 plus 5 root 3. Okay, so it's just same numbers, opposite sign, or your inverse sign, I guess technically. So, if I multiply mine 2 over 3, root 3 plus 2, if I multiply that by root 3 minus 2, or I've made a mistake up here actually, I have to do the same thing to the top and the bottom, so that becomes minus 2 as well. Then what I'm going to get up the top is relatively easy. I'm going to do it just a little bit longer, or with more steps, just so you can see exactly what I'm trying to do. That will become root 3 plus 2, root 3 minus 2, that's a 3 by the way. There we go. Now, I don't know if you remember, if you're aware of this, some of you might have picked this up already. If I have a look at this one here, root 3 plus 2, root 3 minus 2, that one looks exactly like the difference of two squares. If I have a squared minus b squared and I factorize that, it becomes a plus b, a minus b. That's exactly what happens in this one here. Notice when I do this a times, a plus b, a minus b, I get rid of all my my middle terms, if you like. What I mean by that is I get rid of all the terms that have a, b in them. The only ones that I've got left are the ones that only have a and only have b. And that's exactly what's going to happen here. I'll do the first one the long way, but then after that I will show you the shorter way. This now becomes 2 root 3 minus 2. The top is relatively straightforward. And the bottom is going to be root 3 times root 3. So first, that's just 3. And then we do first FOIL inside, plus 2 root 3. And then outside, minus 2 root 3. And then last, 2 times negative 2, which is negative 4. Now, as you can see, 2 root 3 and minus 2 root 3 will disappear, we can ignore them. And then all I've got is the first term squared, which is root 3 squared, which is 3, and then the last term squared, which was, positive 2 and negative 2. So that's negative 4. So I guess the answer follows on from this, so it'll be 2 root 3 minus 2 over 3 minus 4, which is negative 1. Now you can write this in a variety of different ways actually. I'm just going to put down a couple of different ways that you might write this. That could be negative 2 root 3, hang on, I'll do a bracket here so I don't confuse people, minus 2. You can do that because I just pull the negative 1 up the top. Or I guess you could also write that as negative 2 root 3 plus 2, because I've multiplied that negative 1 into both of them. Or it could also be 2 minus 2 root 3. It's just that one there, but I've rearranged it. You could get any one of those answers. They're all acceptable, all okay. All would get full marks in the test. Okay? So, just to sum up, I need to multiply this by the conjugate. I've got a couple of more examples here that we can have a look at. Okay. So, first of all, I need to identify the conjugate of this one. The conjugate of that is multiply the same numbers, so 2 root 2 and root 3. There's no shortcuts here like there was in the other one. You can't drop the 2 at the front. You must have the entire thing on the bottom. This becomes, and then I write 2 root 2 up the top and root 3 up there. Same numbers, different sign, positive instead of negative. Now, this becomes 2 root 2 plus root 3 over 2 root 2 minus root 3, 2 root 2 plus root 3. Okay, that then becomes 4 root 2 plus 2 root 3 over. Now this one I'm going to do, I'm going to ignore some of the terms because of the FOIL thing. Those middle terms, like these ones up here, are going to disappear. I'm just going to be left with 2 root 2 squared. Now 2 root 2 squared is the same as, I guess, 2 root 2 times 2 root 2. That's the same as 4 times root 2 times root 2, which is just 2. So the whole thing is 8. Minus root 3 times root 3, which is just 3. Hopefully I haven't jumped too many steps. You can see what's going on there. If you don't, just ask me in class. So that becomes 4 root 2 plus 2 root 3 over 5. Now, that is exactly the same as this, what we started with. The only difference is now I have a rational denominator, which is what I want. Okay, one more example. The questions that you'll do in this exercise do get quite challenging actually. You'll add two fractions together. Have a go at those by yourselves, but if you do have some questions, please ask me about it. But I'll let you sort of go for them at the moment. Now this, I want to get rid of this square roots on the bottom, so I need to multiply by root 5 and root 2 over root 5 and root 2. The conjugate is the same numbers but a different sign. So that becomes, I don't want to confuse that with that, so I'm just going to do that. That's a 5. Okay, this becomes, I'm going to do this in a couple of steps. Notice how the top is actually the same. I could have written just one of them squared, but I didn't. That's alright. Root 5 minus root 2, root 5 plus root 2. Okay, now the top. I'm going to deal with the top first. I'm going to change colours just because I can. The top. Now don't be lazy with the top one, and don't sort of make these mistakes. When there's a plus and a minus, the middle terms will cancel out. But if there's a plus and a plus, the middle terms won't cancel out. Let me show you what I mean by that. We'll do the FOIL on this first, which is root 5 times root 5, which is just 5. And then inside, root 2 times root 5, plus root 10. Outside, plus root 10. And then the last. plus 2. Notice how here you've got a plus root 10 and a plus root 10, which means you have to add those together so it becomes 2 root 10. I'll deal with that in the next line. Actually, no, I will do that. I still need to do the bottom, but I'll leave a space for that. That becomes now 5 plus 2, which is 7, plus 2 root 10. And it's over something that I don't know yet. So, the next bit, this time I can do FOIL, and because there's a plus and a minus, the middle terms will cancel out, just like we had in the previous things, just like difference of two squares. That becomes root 5 times root 5, which is 5, and negative root 2 plus times root 2 becomes minus 2. So that then becomes 3 on the bottom. Now I can't simplify any of these things any further, so that's the finish of what I got. So in order to get rid of the square root on the bottom when you've got it added to something, whether it's added to another surd like this, or whether it's just added to a number, you need to multiply by the conjugate. And remember, the conjugate is the same numbers but the inverse sign. Hopefully that makes a little bit of sense. You can ask me some questions in class if you need to.